Subscribe to our YouTube channel and press the bell icon to get the latest updates.
On July 3rd Indian time at about 8 p.m., there was a huge solar flare from the sun. It was a large, powerful solar flare and it released a tremendous amount of energy. This flare then caused a strong radio blackout over the Atlantic Ocean. This was the first large flare of the current solar cycle and was an X-class flare, which is one of the most powerful kinds of flares to come out of the sun. In this video, we'll look at solar flares, at coronal mass ejection, the sun's cycle, the effects of solar flares, and sunspots. I'm Sandhya Ramesh, and this is Pure Science. A solar flare, as the name suggests, is a sudden increase in a flash of energy output from the sun, visible as increased brightness near the surface of the sun in a particular spot or a location. Usually, flares are also close to sunspots as well. Solar flares are classified into 5 classes. They are indicated by the letters A, B, C, M, and X. X class is the most powerful, of course, and what we're quantifying into this classification is the quantity peak flux range at 100 to 800 picometer watts per square meter. Within these classes, the strength of the flare event itself is numbered from 0 to 9. This July 3rd solar flare was X 1.5. Typically, solar scientists get excited about Class M and Class X flares more than C or anything lower. This time, we actually had a C class flare first and then an M and then an X class. In fact, even on Friday, we had C class flares. On July 3rd and 4th, in just a span of about 24 hours, we had 3 radio blackouts on the day side. Now, multiple flares like this is actually common, much like earthquakes with foreshocks and aftershocks. We have these flares that are of varying strength, releasing varying amounts of energy. Solar flares can also be accompanied at times by something called a coronal mass ejection, where plasma from the surface of the sun is released in significant amounts into the solar wind. If it is directed towards the Earth, it hits the magnetosphere and something called interplanetary coronal mass ejection occurs. The shock wave from this mass of plasma that is bursting out from the sun actually compresses the magnetosphere at the Earth on the day side, and then when the magnetosphere reconnects on the night side, the energy is released. This energy then goes back up into the atmosphere and it causes geomagnetic storms. A geomagnetic or a solar storm is a disturbance in the magnetosphere and can disrupt several things, including compasses. They can bring aurorae to very low latitudes and they can cause power grid blackouts. There are a couple of famous instances of very powerful solar flares and geomagnetic storms that did this. The 1989 geomagnetic storm actually disrupted power distribution in Canada and it brought aurorae all the way down to Texas. There was also the Carrington Event, which disrupted telegraph systems. Now, the underlying cause behind solar flares and coronal mass ejection is basically something called magnetic reconnection. When two oppositely directed magnetic fields are brought together, their magnetic lines rearrange and reconnect. This process is called magnetic reconnection and it causes magnetic lines to twist and warp, sometimes going up to almost a helical structure. This causes stress in the magnetic fields, leading to one day a sudden release of energy. With the flares that occurred this month, none of them actually had coronal mass ejection, including the powerful X-class one. What was unique about the solar flare though is that it also created something called a magnetic crochet or a solar flare effect. This one produced a radio burst and an ionospheric disturbance and a deflection in local magnetic fields on the ground and a sudden surge of electrical currents in the ground. Of these, the deflection of magnetic fields locally is supposedly especially rare. This is caused by a spike in X-ray radiation that is generated by the solar flare. Magnetic crochet are rare because of multiple reasons. One is that they can be detected while the flare is in progress. then they are only observed during large flares which tend to peak very quickly. They are also typically observed in locations where the sun is overhead. A previous recorded instance of a magnetic crochet actually occurred in 1997 as well. This solar flare was the first X-class solar flare of the current solar cycle, which is solar cycle number 25. A solar cycle is the change in sun's overall activity as measured by variations in sunspots. Sunspots actually are just temporary regions on the sun of reduced temperature. They're caused when magnetic flux prevents convection and thus heat transfer, and they can actually last anywhere from a few days to even a few months. Very large sunspots or large groupings of sunspots can actually be even visible to the naked eye. Sunspots typically make a reappearance every 2 weeks or so as the sun rotates and the same part of the sun comes back to view. Now, each solar cycle actually spans a period of 11 years, during which the magnetic field of the sun flips. The flip occurs when the sunspot cycle is at its maximum, and all solar activity, like sunspots and flares, also follow this 11-year cycle where the activity goes from active to quiet to more active. While sunspots were actually first observed by Galileo in the early 1600s, they started to be documented by the 1700s, extensively and meticulously. But it was only in 1843 that the solar cycle was discovered. The system then continued using numbers that were used in the 1700s to mark sunspots. We've in fact actually gone back and reconstructed sunspot numbers over the past 11,000 years or so using carbon dating and evidence of solar activity from trees. Now we are in solar cycle 25, which began in December of 2019. Many predictions have been made for what these 11 years are going to be in terms of solar activity, and it is in fact expected to be similar to cycle 24. Solar maximum is actually expected to occur between 2023 and 2026. Now, solar flares actually produce a high amount of highly energetic particles in the solar wind, and this influences space weather. There's no matter in space, so space weather is all radiation and solar wind or ionized particles and plasma that's coming from the sun. All the matter from the sun can hit the Earth's magnetosphere and disrupt communications and satellites or cause radiation hazards to the International Space Station and astronauts in space. This is space weather, and it is important to monitor it and predict it if and where possible. And that is something that we are going to see improving over the coming decades for sure. There are many places that already forecast space weather and monitor it, including in India, such as ISER Kolkata's Center of Excellence in Space Sciences, India. The US even has enacted a law to improve their ability to forecast space weather. At this point, many solar scientists and space experts believe that now India should also start taking steps very quickly to monitor space weather. Before I conclude today, I want to bring to your attention that we have now rolled out YouTube memberships. There are many benefits to being a member of this channel, including early access to our YouTube videos, personal responses to comments and queries from those of us who do our shows directly, community content, loyalty badges, and much more. So please do join by clicking on the join link below and be a part of our lovely community. Thank you for your support.